Now we've done some work on factorising quadratics, let's take a look at another special situation. Let's take a look at the difference of two squares. Now if you remember from expansion, the difference of two squares says that if I've got ax plus b and ax take b as my two linear factors, that this is equal to this first term squared subtract the second term squared. So subtract my b squared. Now I can rewrite this obviously as a squared x squared subtract b squared. Now what we're trying to do here is go back the other way. So if I've got something like this, how do I factorise it back into this? Well, let's take a look at a problem. Let's say I had 4x squared subtract 9. Well, what I want to do with this problem here, you can easily see that I've got my x squared lined up. My a value is hidden a little bit because my a's got to be squared to equal 4. So to find what my a value is, I need to do the square root of 4. Now the square root of 4 is technically plus or minus 2. Because negative 2 times negative 2 will equal positive 4, but also 2 times 2 will equal positive 4. But at the moment, when we're doing the difference of two squares, the signs don't really matter. So what we can say is this is equal to 2 squared, x squared, and then we do the same with our b value. So the square root of 9 can be plus or minus 3, but we're just going to use the positive value here. So subtract 3 squared. And this is equivalent to this. But what it allows us to do is to very quickly identify what my a and my b values are. So my a value here is equal to 2, because you can see that easily now. And my b value here is equal to 3. And when I've got my a and b value, I simply substitute those back into this format here. So when I factorise this now, this is going to be equal to my a value of 2, so 2x, then plus my b value, so plus 3, and then it's going to be my a value of 2, so 2x, then subtract my b value, so subtract 3. And now what I've done is I've now factorised this into the two linear factors using the difference of two squares. But we can always check to make sure we've got this right, as we can with any sort of factorisation. So let's do that. Well, as we expand this out, we will expand the first, so 2x times 2x will be 4x squared. Then 2x times negative 3 will be take 6x. Then 3 times 2x will be plus 6x. And then 3 times negative 3 will be take 9. And now what we'll need to do is to collect like terms. So we'll still have our 4x squared, subtract 6x plus 6x, they're opposites, they cancel. So it'll just leave us with 4x squared subtract 9, which is what we had to begin with. So we've factorised this here correctly using the difference of two squareds. So when we've got the difference of two squareds, the key here is to square root each term essentially to be able to find what the a and the b value are. And then you substitute those values back into the difference of two squareds that we had to begin with.